Okay, we are going to do section 9-4, rational expressions. Your directions are to simplify each rational expression. State any restrictions on the variables. So let's take a look at example 1. So you have a trinomial divided by a trinomial. So in order to simplify this, we're going to have to factor. So we're going to practice all your factoring again in this section. So let's get this set up nicely. Okay, and let's go ahead and factor. So we're going to factor. This means same signs. They're both going to be plus. So we're going to add the pair to give me 10. And then product of 25, so that's going to be 5 and 5. Okay, and then x squared plus 9x plus 20. Same signs, both going to be plus again. And then we are going to do x plus 5 and x plus 4. Gives me my product of 20 and my sum of 9. Now, we have factors here, so we're going to cancel complete factors. So this cancels and this cancels. The whole entire factor has to cancel. Then we have left x plus 5 as the numerator divided by x plus 4 on the denominator. So that's your simplified expression. Now you need to state any restrictions on your variables. So that goes along with your domain restrictions that we've talked about in the past. So the restriction here, again, I'm going to write your restriction. So the restriction here is the denominator cannot be equal to 0 because we cannot divide by 0. That's a problem. So we take both of our factors here. Yes, they've been canceled out, but they still affect the entire problem. So we need to look here in order to find our restrictions. So basically we're going to say x plus 5 equals 0, and we're going to solve for x to see what it can be equal to here. And then x plus 4 is equal to 0, and then x is equal to negative 4 here. So we know that these are the numbers that make it equal to 0, so we are going to restrict them. We're going to reject them. Okay, so our final answer is x plus 5 divided by x plus 4, but x cannot be equal to negative 5 and it cannot be equal to negative 4. So this is our final answer right here. Okay, here's another set of directions. Multiply or divide. State any restrictions on the variables. Okay, so here's example 2. I'm just going to start down here and work all my way over here. Okay, so here's my first example. Now, since this is a 2 as the leading coefficient right here, we're going to see if we can factor these easier ones first and then see if these factors will help me factor this one. Okay, so we're going to set this up. This is going to be factored into this divided by x minus 4. Can't do anything with that. And then this is going to be factored, and then this will be factored. So we're going to fill these in. Okay, so let's start with this one right here first. Okay, we're going to skip this for a moment because this is a harder one to factor. So we're going to use our work to help us factor this one last. So x squared minus 16, that's a difference of 2 perfect squares. So that's different signs. And we're going to do the square root of 16, which is a 4. So that's what that factors into. And then this down here, same signs, both going to be plus. And the factors of 15 that add to an 8 are 3 and 5. Okay, so now when I factor this top up here, okay, since this is a 2, I know one of these has to be a 2 and one has to be an x. It's the only way we're going to get a 2x squared. I also know that the signs have to be the same and this means same signs, they're both going to be plus. So I put those in there. Okay. Now, the only factors of 3 are 3 and 1. Okay. So I just need to know, does my 3 go here or does it go here? Well, the whole object is to get these factors to cancel out. So let's try and see if x plus 3 will work, because there's an x plus 3 right here. Okay, so x plus 3, so the only factor from 3 that's left with 3 is 1. Okay, so then when we check this, let's do a little check here. Okay, this is going to be a little crowded, so let's see what we can do here. So this is 2x times 3, so that's a 6x. And then this right here is my 1x. And then when I actually, that's an x. So when I actually add those together, 6x and 1x does give me my 7x. So that does factor. So that is great. So what's so nice about this now is put this in parentheses because it's a factor as well. And let's cancel our complete factors. So x minus 4 cancels with this x minus 4. X plus 3 cancels with this x plus 3. We use this to help us factors. Then it's not so difficult with the leading coefficient bigger than 1. Then we will look at our final answer. So we're going to have 2x plus 1 left on top. See if I can squeeze this in here, I guess. So that's 2x plus 1. And then x plus 4 is what's left on top. And then what's on the bottom is just my x plus 5. So you need to write very neat so you can read your handwriting and see what's left. You don't need these in parentheses down here, but we'll put it in so it looks nice. All right, now when we do our domain, we have to state any restrictions on the variables. That means our denominator cannot be equal to 0. So again, my restriction is my denominator cannot be equal to 0. And we've done this over and over. Okay? So what you're going to do is I'm going to star your restriction, all of them. So it's this one, and this one. You have to take every single factor down there on your denominator and do your restriction there. Okay, so this would be x is equal to 4. I'm not going to do the solving because we've done that over and over. So x is equal to 4. X is equal to negative 3 when I actually solve for 0. And x equals to negative 5. Okay, these are my restrictions. All right. Okay, so over here I have to say that x cannot be equal to 4, negative 3, or negative 5 because that's where x is, when x is 4, negative 3, and 5. And then I'm going to write this as my restriction over here. And then this is my final answer right here. I don't have room to do my final statement, so there's my final statement right there. Okay, this is example 3. This will be our last example for this section. So notice this is divide. Okay, so it says multiply or divide, so we're going to divide on this one. And again, we're going to state our restrictions on the variables. Okay, so the only variable we have here is x. Okay, you can have any variable here. All right, so what we're going to do first, so that we don't make a careless error, is we are going to rewrite this. Okay, and when we divide by fractions, we have to multiply by the reciprocal. So we're going to flip these two. Okay, so I'm going to rewrite this, and yes, I'm going to show my baby steps. So yes, I'm going to rewrite this. Hopefully I'm going to write it a little bit smaller so that I can fit it all on there. Times, this is going to change to a times, and then these are going to flip. So this is going to come up here, x squared plus 7x plus 12, and then divided by x squared minus 9. Okay, so now this is Actually, I think I will have enough room, so let me just go on down. Okay, so now we're going to get things ready. So this is just going to be x plus 3 divided by, we're going to get this ready to factor, times, get this ready to factor, and this ready to factor. Okay, so that's done up there. We could put that in parentheses so it looks like a factor. It is. So then I've got x squared plus x minus 12. This is going to be different signs. So then I've got x plus and x minus for my different signs. The numbers that multiply to 12 but subtract to a 1 is positive 4 and minus 3. Up here I've got same signs. They're both going to be positive. So x plus 4 and x plus 3 work on this one because this adds to 7 and also multiplies to 12. And then this is a difference of two perfect squares. So that's going to be different signs, and the square root of 9 is 3. So that's why that's a difference of two perfect squares. Then we're going to cancel our factors. So x plus 3 and x plus 3. I could have taken that one. That's okay. X plus 4 and x plus 4. Double check to see if there's anything else that needs to cancel. Everything has to be exactly the same in the factors to cancel. Then we're going to write our simplified answer. The numerator ends up being x plus 3 divided by, you don't have to put that in parentheses, you can if you want to. And then x minus 3 quantity squared is how we write that in simplest form. Okay? Now we need to do our restrictions. Okay? So when we look at our restrictions, we have to look at our denominator. So here's our denominator right here. Okay? Alright, so I need to take a look at x plus 4 is something different. And then I've got an x minus 3 is something different. And then I've got an x plus 3 here. Okay? So and when I set this equal to 0, I know you don't have to do that anymore. Okay, so your restriction is your denominator cannot be equal to 0. Okay, so I'll just write your denominator cannot be equal to 0. I'll just write restrict here if I can fit it. Okay, so here's abbreviation. Alright, so your denominator cannot be equal to 0. So that means when I solve this, okay, that means that x is equal to a negative 4 here, x is equal to 3 here, x is equal to 3 there, and x is equal to negative 3 here. Okay? Alright, so that's when x is negative 4, that gives me a 0, and so on. Okay? But we cannot be equal to 0, so we're going to reject those. Now, do not forget, up here was your original denominator. That's taken care of down here. This original denominator actually turned up to your numerator. So don't forget it here. Make sure that this is not something different. Okay, now you already know what this factors into because it's right here. So this is x plus 4 and x plus 3. Okay, so you need to double check up here at this denominator. Even though it's under division, it's still my denominator from the beginning. You have to do all your denominators from the beginning. So then you've got x plus 4 and x plus 3. I've got that here. That's taken care of. And x plus 3 was taken care of right here. So we're good to go here. So then that is going to be your restrictions then. So then x, but x cannot be equal to negative 4. I'm just going to put this in numerical order. Negative 3 and 3. And there is your final answer. Okay, I decided to do one last example so you can kind of see why you have to come back up here to this denominator. Okay, this is already in factored form, so this will be nice. So that you're going to again circle your division. It's always good to do another example here in division. Alright, so when we divide we are going to multiply by the reciprocal. So we're going to flip those two right there. Okay, so notice I leave this one alone. So I've got 4 minus x over quantity 3x plus 2 times the quantity x minus 2. So I just write that down. Times, flip this. So this comes up top, x minus 2, and 7y minus 5. Divided by, this goes down on the bottom. So 5 times x minus 4 for your denominator. Okay? Alright, so then let's just cancel the factors we can. So x minus 2 and x minus 2 cancel. Okay? Now these really do cancel into each other. Alright? This is x minus 4, this is 4 minus x. So it's actually going into each other negative 1 time. Okay? So that's actually canceling out. This is a negative 1. These are opposite signs. And then this is going into there. So that's what that's going to be equal to. Okay, so then your final answer I'm going to write down here. So I've got negative 1 times 7y minus 5 left on the top divided by 3x plus 2 on the bottom. Okay, and 5. So I'm going to just scoot this over and put my 5 right here. Okay, so nothing cancels anymore. That's all that's left. Okay, and then we will probably do this one out. So this would be negative 7y plus 5. Okay, so you want to put your negative through like that. And then you can just leave this because this is in vector form here. So this would be 5 and then 3x plus 2. Okay, actually either one of these are correct. You'll probably see this one more often, so we'll leave that right here. This will be the common answer here. Okay, all right, now I need to take a look at my restrictions, okay? Because I know that my denominator, so my restriction now, my restriction, pardon me. So my restriction, again, is my denominator cannot be equal to 0. Okay, so my denominator cannot be equal to 0. Okay, so when I set it equal to 0 and I solve for it, then I will find out which ones I'm going to reject. Okay, so I think I'm going to put that here because I have space. So I'm going to have to bring this over here. So I've got 3x. We can just ignore the 5 because it doesn't have an x with it. Okay, so this is my variable. It doesn't have to be an x. As you can see, there's a y right there. So I've got 3x plus 2 is equal to 0. So when I solve this, I'm going to get x is equal to a negative 2/3. Okay, so we've done that. Baby steps probably aren't required there. They're not required. You don't need them probably. Okay, so this right here is my denominator. So I needed that piece right there. Now, don't forget, you need to come back up here and make sure, because this is really a denominator and this is really a denominator. Okay, so make sure that all of your denominator factors are taken care of. This one is taken care of here. We've got that one. Okay, this is the same one. Okay, so I've got that taken care of there. X minus 2 is actually here also. So I'm going to take them from here and I'm going to take it from here. Okay, so I've got to take this one and this one. This is just a repeat, so I'm going to take this one. So when I do this, you can see these pretty quickly. This is x is equal to 2 when I solve for 0. Okay, and then this one right here is 7y minus 5 equals 0. Okay, so then when I solve that, that means that y is equal to 5/7. Okay, so that's what we have here. So we need to take these right here and we need to restrict them from our answer. Okay, so then we say x cannot be equal to negative 2/3. We usually do it in least to greatest order. So negative 2/3. Then we've got 5/7, and we also have 2. So you have to go back up to your original denominators way back from the beginning of the problem. So don't forget to do that. And here is your final answer, right here in this cloud. Okay, thank you. And we'll see you in class tomorrow.